Electric potential energy. Electric potential energy is the energy or work needed to move a charged particle against an electric field. For example, here electric field is from positive to negative. So this positive test charge to move from point A to B, from point A to point B against the electric field, some external force is required because these positive charges are repelling this positive charge, and these negative charges are attracting this positive charge. So to move against the electric field, we need some external force. As a result of a force, a body covers distance means a work is done. Work is force and displacement. Under the action of external force, a body covers some distance. Under the action of force, a body covers distance means work is done. Here the work is done. And this work is stored as a electric potential energy. And this as electric potential energy in this charge. Same like gravitational potential energy. If I'm applying force on this tester right now and it covers some distance, means a work is done. And the work is stored as a gravitational potential energy in this tester. It has energy. It can damage if I release it. Anything that is placed under the duster, it depends upon the mass of the duster or anything. Same here. Here the energy is stored as a gravitational potential energy. Gravitational potential energy. Here the work is stored as a electric potential energy. Consider a constant electric field E and a charge Q is moved through a distance R. Then work will be force and displacement. Displacement is represented by R and force F is applied. Now we know that electric field strength E is equal to force per unit charge. The Q will be multiplied with E, F is equal to QE. By putting the value of F, work done is equal to QER. And this work which I done on this charge is stored as a electric potential energy, and electric potential energy is represented by U. So the work is equal to U. So U is equal to QER. It's the electric potential energy, and it is measured in joule because it is in energy. Electric potential energy is measured in joule, and joule is equal to Newton meter. The work is measured in joule, force in Newton, distance is in meter. Joule is equal to Newton meter, and its dimension is ml square T power minus 2. Now, conservative force, conservative field. Conservative force or field. Electric field is conservative field because it doesn't depend on the path followed. It depends only on the initial and final position. For example, if the charge is moved through this path to point B, or through this path or through this path, the energy will be same at point B because of the repulsion of these positive charges. It doesn't depend either the charge is moved from this path, or straight from point A to point B. The energy is because of these positive charges and because of these negative charges. So it doesn't depend on the path, means it doesn't depend on the path, it only depends on the initial and final position. So the field which doesn't depend on the path is known as conservative field, and the force which doesn't depend on the path is known as conservative force. Electric force is a conservative force, means work done doesn't depend on the path followed but only depends on the initial and final position. Only initial position is A, final is B. It depends on the initial and final position. Gravitational field is also a gravitational conservative field, because if the duster is moved from this position to this position through this path, through this path, the potential at the same height, the potential energy will be same. So gravitational field is also conservative field. So because the work doesn't depend on the path followed, and the gravitational force is conservative force. Now it's a electric potential energy. Now what is electric potential? Electric potential is work done per unit charge. Electric potential energy is the energy or work. It is measured in joule. It is measured in joule per coulomb. Work is measured in joule, charge is measured in coulomb. Electric potential is the joule per coulomb, and this work is stored as a electric potential energy. So the work is equal to U, and electric potential energy is represented by U. So V is equal to U over Q. V is the electric potential, U is the electric potential energy, or W is the electric potential energy. So it is measured in joule per coulomb or volt. It is measured in volt, which is equal to, it is measured in volt, which is equal to joule per coulomb. And its dimension is ml square t power minus k power minus 1. Now, work is equal to force F dot D, force in displacement. In magnitude form, here cos 180, because the work done against the electric field. For example, electric field is from positive to negative in this direction, and we moved the charge from point A to point B in this direction. So the angle is 180. The work is done against the electric field lines. Electric field lines is from left to right, and the work is done from right to left. The angle is 180. That's why 180 comes here, cos 180 is minus 1. As we know that electric field strength is equal to force per unit charge. Q will be multiplied with E, F is equal to QE. By putting the value of F, electric field, electric potential in terms of electric field and distance. And electric field strength, I already explained in previous lecture, electric field strength E is equal to KQ over R square. By putting the value of E, KQ over the R and the square will be cancelled. Electric potential in terms of charge and distance. Electric potential is directly proportional to the magnitude of charge and inversely proportional to the distance from the charge. For more than one charges, I'm removing for the simplicity. For more than one charges, sigma means sum of all, KQ over R, KQ over R, this same. Sigma means sum of all. For more than one charges, electric potential will be equal to the sum of all the electric potentials. For example, there are 10 charges, then I will be equal to from 1 to 10. The total number of charges is n. So for I is equal to 1 to n, the sum of all. Now applications of electric potential. The applications in uh, electronics, electron microscope, mosquito rockets, etc. Lots of application. What is absolute potential energy? Electric potential energy, electric potential, now absolute potential energy. Absolute potential energy means, for example, a positive charge. This positive charge has the range in this region. So a charge at this point is at infinity. Infinity means out of range. This charge is out of range. So it's at infinity with respect to this charge. So to move a charge from infinity to that point, energy required to move a charge from infinity to that point is known as absolute potential energy. Yes.